Hi everyone. So today we're going to use our prior knowledge of adding and subtracting fractions as well as simplifying rational expressions to basically solve rational equations now. So I do want to go over two types of rational equations that we'll be dealing with, and I want to just think about them in terms of simple fractions first. That way we can apply that knowledge to solving the rational equations. So the first type that we're going to see is when one rational expression is equal to another rational expression. So you have one fraction basically equal to another. So the method to solve this is to cross multiply. So I want you to think about simple fractions. Let's say 2/3 equals x over 6. Okay, we would cross multiply. So we have 3x equals 12, and we know that x equals 4. And all you did was cross multiply and then just solve for the variable. We're going to do the same kind of steps when we're solving the rational equations. So keep that in mind. Now the second type is when you have a sum or difference of rational expressions that's set equal to another rational expression. Now to solve this, the method you're going to use is to multiply everything by the LCD. So if we think in terms of simpler fractions, let's say I have 2/5 plus x over 10 equals 14 over 20, and I'm trying to solve for x. My LCD would be 20 in this case. So if I multiply every single term in this equation by 20, I should get something that's still equivalent to the original. So I'm just going to write multiplying by 20 next to each term here, just so you can see what I'm doing. Okay, so you'll notice that in the first fraction, I get 40 over 5, which simplifies to just 8. And in the next one, when I multiply by the LCD, I get 20x over 10. 20x over 10 simplifies to just 2x. When I multiply the last fraction by 20, I end up getting just 14 when I simplify. So I want you to keep that in mind when we're going through these as well. Now that when we get to this point, 2x equals 6, and x would then equal 3. So for this one, remember, you're basically multiplying every term by whatever the LCD is. Some things might cancel, you can simplify each fraction, and then we end up getting just this here, your 8 plus 2x equals 14, which is much simpler to solve. So let's look down below in the examples and practice some of these, just keeping these two methods in mind, and I want you to be able to identify which method to use for all of these. Now notice that it does say to remember to check your solutions. There could be extraneous solutions, and remember that just means that we could possibly get solutions that don't actually work when we go and plug them back into the equation. So for the first one, I have one fraction set equal to another fraction. So this is actually a type number 1. And for that, I'm going to cross multiply. So I have 5 times x squared minus 1 equals 15 times 2x minus 2. When I distribute, I get 5x squared minus 5 equals 30x minus 30. I can set this equal to 0, so I have 5x squared minus 30x plus 25 equals 0. Take out a 5. Now I can use the sum product rule, and I get 5 times x minus 5 times x minus 1 equals 0. And at this point, my two possibilities are x equals 5 and x equals 1. Now, to check for extraneous solutions, you're going to go back and see if either of these values of x will make the denominator equal 0. And if they do, it's not a possible solution. So I can plug in 5 and nothing in the denominator will be 0. However, if I plug in a 1, I will get a 0 in the denominator. So I'm going to have to say that x equals 1 does not work, and my only possible solution is x equals 5. So remember to always check. And you can just do that by plugging in your number. So 5 over 2 times 5 is 10 minus 2 equals 15 over, let's see, 5 squared is 25 minus 1. So does 5 over 8 equal 15 over 24? And yes, it does. Okay, so now let's look at the second one. And again, we need to identify which type it is first. So I have a difference of two rational expressions set equal to another. So this is going to be type number 2. So I'm going to have to find an LCD for this. To do that, remember, we're going to factor the denominators first. So I have x squared plus 3x plus 9 over x times x minus 3 minus x plus 6 over x minus 3 for the next fraction set equal to negative 3 over x. I can now determine my LCD, which in this case is going to be x times x minus 3. So I'm going to multiply every single term in this equation by x times x minus 3. Now when I do that, notice what's going to cancel in the denominator if I multiply the numerator by x times x minus 3. Those are going to cancel out, and I'll show you what it would look like here. So I can simplify by canceling those out, so I'm left with just what lives in the numerator already. This is essentially what we're doing for each term in the equation, and I'm going to write it out now just so you can see, but when we move on to the next example, I'm not going to write it out just because it's a step that you can do in your head, but I will show you why it works in this example. So now if I multiply x times x minus 3 times x plus 6 over x minus 3. Now look at what cancels here. So I'm just left with x times x plus 6. This is equal to negative 3 times the LCD. Now here, notice what I can cancel out. So I'm just going to rewrite what's left over. X squared plus 3x plus 9 minus x times x plus 6 equals negative 3 times x minus 3. Okay, so now I can simplify to solve the equation for x. So I have x squared plus 3x plus 9. Remember that this subtraction is really attached to this x. You can think of it as a negative. So I get negative x squared minus 6x set equal to negative 3x plus 9. Now I can combine like terms. I end up getting negative 3x plus 9 on the left, and I also have negative 3x plus 9 on the right. At this point, because the left side equals the right side, we're going to have all real numbers as our solutions. However, we still need to see if there's any restrictions, anything that will make the denominator equal 0, because those will be extraneous solutions in this case. So if I look in the denominator, x cannot be 0, and x can also not be 3. Okay, so those are extraneous solutions. So every real number will work in this except for when x is 0 or 3. So let's move on to the third example. So again, I have a sum of two rational expressions set equal to another. So again, this is type 2. So I'm going to have to find an LCD. And we'll find that by making sure that all of the denominators are factored. So this last expression becomes x minus 1 times x plus 1. And now I can determine that my LCD is equal to x plus 1 times x minus 1. So again, I'm going to think about multiplying every single term by x plus 1 times x minus 1. So when I do that, for my first term, I'm just left with x minus 1 because the x plus 1's basically cancel out. In the next term, I'm left with just x plus 1. And in the last term, I'm just left with 2. So I end up getting 2x equals 2, x equals 1. If I think about checking that, 1 will make the denominator equal 0. So since this makes the denominator equal 0, my solution is actually no solution for this. We're going to follow the same steps for example number 4. Again, this is type number 2. So I'm going to find the LCD. So I have 3 over x plus 5. Now here I do have to make sure that the x comes first in the denominator. So I have 2 over a negative x minus 5. And that is set equal to negative 4 over x plus 5 times x minus 5. Now just remember that this negative is just going to turn this fraction into subtraction instead of addition. So I have 3 over x plus 5 minus 2 over x minus 5 equals negative 4 over x plus 5 times x minus 5. My LCD is x plus 5 times x minus 5. So when I multiply each term by the LCD, let's look at what is left over. So my first term becomes 3 times x minus 5 because the x plus 5s will cancel out. I'm subtracting 2 times x plus 5 from that because the x minus 5s cancel. And here I just get it equal to negative 4. So 3x minus 15 minus 2x minus 10 equals negative 4. Combine like terms, I have x minus 25 equals negative 4. Add 25 to both sides, x equals 21. Now let's just check that to make sure that it is not an extraneous solution. So if I plug in 21, I end up getting 3 over 21 plus 5 is 26. Plus 2 over 5 minus 21 gives me negative 16. And we want to see if that equals negative 4 over 26 times negative 16. And the left side is indeed equal to the right side, so we know our answer for this is x equals 21. So now it's time for you guys to practice some on your own. I suggest making sure you can identify the type first and which type is associated with which method. Remember to always check for extraneous solutions at the end. I have attached a QR code hint sheet, and if your teacher provided it, you can use the sheet to help you with examples 5 through 9. The last example does not have a hint to go with it, because hopefully by then you are more used to these. But if you do need a hint, you can scan the QR code for the example that's listed there. Good luck!